Please do not swear. Right, okay. Homework. We looked at a lot yesterday. We went through a lot yesterday. Right, okay. And I had the book open and now it's closed. What page am I on? Yeah. So I gave you 1 to 6 on page 292. Is that right? Okay. Will we go through them just in case something crops up? And I want to talk about the line of best fit as well because it crops up in some of them. Okay, so we do the line of best fit as well today. Okay, right. So match one of the following numbers with each of the graphs above so that it best represents the correlation. So look at the numbers. 0.1, that's very nearly 0, so that's pretty much no correlation. Minus 0.4, it's a line coming down, but it's nearer to 0 than it is to minus 1, so it's pretty scattered, right? 1 is a perfect line going up, minus 1 is a perfect line coming down, right? 0.6 is it's past halfway. It's a line going up because it's positive, but it's pretty shaky. Okay, minus 0.8 is nearly a really good line coming down, and 0.8 is a really good line going up, right? Okay, so what did you put on A? It's definitely what anyway? Definitely positive. Is it perfect? No, so it's definitely not plus 1. So it can be 0.1, 0.6 or 0.8. 0.1 is very near 0, so it's definitely not 0.1. So it's 0.6 or 0.8. What did you put on it? 0.6. I think I put 0.8 on it, would I? What did you put in it? 0.6. We'll go with 0.6. So, right, okay. B, it's a minus. It's definitely a minus. It's coming down. It's pretty perfect. So what did you put in it? Minus 1. The other one is C is coming down. So it's definitely a minus. So it's either minus 0.4 or minus 0.8. What did you put? Minus 0.4, yeah. And then the other one is a line going up. D is a line going up, so it's definitely positive, and it's good, right? As in they're quite close together, aren't they? So did you put 0.8 on it? Yeah, right, good. Match one of these correlation coefficients to each of the descriptions below. So we've no diagram. Strong positive correlation. Strong positive. What you put? 0.9, lovely. Strong negative? Minus 0.8. No correlation? 0. Perfect negative correlation? Minus 1. Very weak negative correlation? Minus 0.1. Very weak positive correlation? 0.2. Right, we get the idea. Yeah, we're all happy? Right. Number 3. Okay, the scatter graph shows the heights and weights of a group of children. A line is drawn through some of these points. What is the name given to the line? Right, we didn't do this, so I'm talking through this now. So it's called the line of best fit, girls. Okay, so when you're drawn, you'll be asked to draw a scatter diagram, and then you draw the line of best fit. Now the line of best fit is drawn to the eye, right, which means my line is going to be slightly different to your line, it's going to be slightly different to your line. Do you know what I mean? We're all going to draw a slightly different line, right? Okay, you try and get close to as many points as possible, okay? And I would try, what I would say is if there was 10 points, I'd be getting 5 on one side and 5 on the other, and maybe hitting a few, right? Do you know, maybe have them, give a quick count, like if there's 50 points, right, okay, give a very quick count, right, okay, so that you've kind of half on one line, half on one side of the line, half on the other side of the line, and go through as many as you can, right? Is that okay? Right, so it's to the eye, so all our lines are going to be different, right? Explain why this is a suitable line of best fit. It goes through a good few points, and it pretty much had the points. There's half on one side and half on the other side. Is that alright? Okay. Use the line to find the likely weight of the child is 150 centimetres in height. So that means you go to 150, you go up, hit the line, go across and read off the value. Do we have an answer there? No, because I told you to skip out that. Yeah. Right, it's probably, we're looking at where are we, 150, is that blue line? Yeah, 55? Yeah, right, we'll go with that. Describe the correlation between the two sets of data. Right, so what would you say? Describe, we've no numbers, they're not asking us to put a number on it, they're just words. Describe means words. So what would you say? I'd say strong positive correlation, yeah. Is that alright? Okay, right. Number 4, use your calculator to get the correlation coefficient. What did you get? 0.86? Yeah, it doesn't say how many decimal places. Oh, they tell you the answer. Read the question, yeah. So, I'll just do it in my head here. Yeah, 0.86, yeah. Did you get that? Yeah. Is that alright? Everybody got it? Everyone's okay with the correlation coefficient? You didn't get it, right, okay. Good. Let's go back to the instructions. Did you write down the instructions?
Yeah.
Right, okay. Let's do it again. So,
my calculator is a bit different.
Right, is it a new one?
No, it's the old ones. It's just
Oh, it's on the one, it's over the one. Right, okay. So, can I go back to the instructions? Right, okay. Clear the memory. Right, okay. Were you able to get the table in?
Yeah.
The two, right, okay. And then you go shift, sorry, I think it's shift to number 1.
Yeah.
Yeah.
Just press 5.
Yeah, shift to number 1. So you go shift and 1. Yeah, and then it's under 5 REG, you tell me?
Yeah.
Right, and it's sigma R is there, it's number 3. Okay? So you have to go shift to number 1, you'll see the stats written over number 1. Same with the standard deviation, that's where you'll find it in there. Except when you go shift and number 1 to find the standard deviation, I think it's under, I think it's 4. Yeah, it's 4 and it's sigma x, okay? So shift to number 1, 4 will get you standard deviation and 5 will get you R, the correlation coefficient. You just have a bit more to remember. Is that right? Okay, right. So plenty of practice and you'll remember it, right? Is that okay? Did we get the correlation coefficient in 5?
0.86.
In 5, 0.86 again? Yeah. 0.86 again? They're messing with our heads. Right, okay. And number 6, right, plot on the scatter diagram. Construct a line of best fit by the eye. I said leave that bit out. Will you do it now? Right, okay. So you need a ruler. If anyone doesn't have a straight edge, come up and... Okay, so there's, wait out, let's see, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 points. So draw a line, right, that goes through as many points as possible, but it halves, like there's 4 on one side, 4 on the other, and maybe hitting 2. Yeah. Diane, thanks.
Thank you.
Right, are we all doing it? So there's 8 points, so maybe go through 2 and have 3 on one side and 3 on the other, right? And as I say, we're all going to be slightly different, right? Okay, find the equation of this line. Okay, so to find the equation of this line, you have to get 2 points off the line, right? 2 points off your line. Use your ruler to get 2 points off your line, right? Okay, and then they don't have to be points in the table. They don't have to be points in the table because your line mightn't go through any points, right? Okay, so you get 2 points off your line, right? You get the slope of it using the slope formula, y2 minus y1 all over x2 minus x1. and then you use the equation of line formula y minus y1 equals m into x minus x1. Right? Are you all confused?
Yeah.
Right, will someone give me two? So, have we drawn a line? Right, have we drawn a line? Have we all drawn a line? Yes. Right, get me one person, I'll go with Alva, I'll go with your line. Give me 2 points off your line. So, use the ruler.
Excuse me, please, could I have a representative from Miss Lyon's careers, 5th year, class 2 reception now, please?
Use a ruler to draw up from the X and over, right, okay? So, say that again? Yeah. 1924 and say that again? 16, 20. Right? They're not on the table now, they're your points, yeah? No. Let's use, you know the way, right, okay, sorry. Right, you're going to have all your points here. 1, 2, 3, 4. I presume it's is it strong positive going up? I'm not drawing it. What is it? It's a negative. Right, okay, so it's strong negative coming down. I'm not drawing it properly, okay? There's 8 points, okay, so we'll just 1, 2, 3, 4, 5, 6, 7, 8. Right, okay, so I'm going to get my ruler. Right, okay, and I'm going to draw a line of best fit, okay, I'm going to go there, right, okay, so I've kind of, there's 4, I've gone through no point, well I've went through that point, but there's kind of 4 on one side and 4 on the other, right, that's my line of best fit, yes, okay, sorry, yeah, sorry, okay, so that's my line of best fit, so now I'm going to get 2 completely new points, right, off my line. So I'm going to get an x value, so I'm going to get my ruler, I'm going to draw a line up to hit the graph, draw a line across, and I'm going to read this x and this y, okay? And then I'm going to get another one, doesn't matter where you get it, I'll go over here, I'll read this x, sorry, God that's desperate, read this x and this y and get a second point, okay? So you don't use the points you drew. Because chances are the points you drew are not on the line, right, okay? Well, there's a good likelihood they're not on the line. If they do happen to be on the line, yes, you can use them, right, okay?
So what points do you use?
Use these 2 points that I just, yeah, you get 2 new points,
Yes.
right, okay? Is that alright? So get 2 new points off your line, okay? So Alva, when you've 2 new points got there, you might tell me what they are and we'll take it from there. 1128, 2216. Right, girls? These are the points I'm using. We're all going to do it together with your points. Okay, so you're using different points. You're using what? Has everyone got 2 points off their line? Right? So we're going to finish it out together. Okay? Right, because we're all going to get different answers. Because we all drew a different line. Okay? So first off, to get the equation of line, you need the slope. So x1, y1, x2, y2. We'll get a bit of revision of coordinate geometry of the line in here. So to get the slope, it's y2 minus y1 all over x2 minus x1. So that's 16 minus 28 all over 20. Is that a 22? 22 minus 11, okay, so that's minus 12 over 11, okay, is my slope, right, is Alva's slope, is that alright? So then we're getting, it says get the equation of line y minus y1 equals m into x minus x1, so you've got your slope and you use one of the points, so we might as well use this one. So it's y minus 28 equals minus 12 over 11 into x minus x1, which is 11. Okay, remember how you sort this out. You go multiply up top by 11. So multiply this both sides by 11, which means this side gets multiplied by 11, and over the other side the 11's cancel, so you're just left with minus 12 times x minus 11. Okay, so that would be 11y minus 308 minus 12x plus 132. Is that right? Okay, and that would be 12x plus 11y minus 388 minus 132 would be, so minus 308, 308, that'd be minus 440 equals naught. Okay, so that's the equation of my line. Right, the equation of your line is different. What slopes did you get? Minus 1? Is it perfect? Is it a perfect straight line? As in, okay, yeah, right, minus 12 over 11 is very close to minus 1. Yeah, minus 12 over 11 is very close to minus 1. Say, yeah, okay, we'll go with minus 1. What else do we get? Other slopes out there? Minus 4 over 5, that's almost minus 1 as well. So we're all in around the same area, aren't we? Right, okay. But actually, girls, there's no right answer. So in the exam, there's no right answer. They'll just look and see, did you pick 2 correct points? Did you get a correct slope with your 2 correct points? Did you get the correct equation with your 2 correct points in your slope? Okay, so like whatever, 30,000 people doing the leading cert, 30,000 different answers, right? All correct, right? If you follow the procedure. Is that all right? Yes.
Does it have to be 2 new points?
Does it have to be?
2 new points, or like let's say you're 9.2 is 1 point. Could you pick?
Yeah, you could pick that point and one other, right? But yeah. So you could use one of the points off the graph if your line goes through it. Okay, but if your line does not go through it and you use it, you lose marks because it's not in your line. Okay, is that alright? Okay, are we all okay with line of best fit? Okay, so it's painful, right? Okay, drawing a scatter graph is painful, right? Especially if there's like 30 points, right? Which there has been, but there's nothing hard about it, right? Drawing a line of best fit and getting 2 points off it and getting the slope and getting the equation is painful, but there's nothing hard in it. And it comes up, girls, right? So, you know, it's I think it's annoying marks, but easy marks to get, right? That's the way I would put it. They're annoying because you have to fool an ape with them, right? Okay, is that all right? Okay, and the last question is that the last question in that was use your equation. Right, so my equation is 12x plus 11y minus 440. So whatever your equation is, that's what it is, equals 0. And it says, use your equation to predict the number of fires in the year with a rainfall of 25. So is rainfall x or y? So they're telling me rainfall is 25 and they're looking for number of fires. So you have to look at the table or your graph. Is rainfall x or y? Where did you put rainfall? On the x-axis or the y-axis? X-axis. So rainfall is x. So we know x is 25 and you're going to solve for y plus 11y minus 440 equals 0. So 12 25s is 300. Yeah, sorry. Thanks. 300. Is that right? It is. Plus 11y minus 440 equals 0. So that means 11y equals 120. No, 140. So that means y is equal to 140 over 11. Now, that's my answer. Your equation is going to give a different answer, but it won't be that far. We won't be that far away from each other. 140 over 11 is about 12, 13, between 12 and 13. So, are we all looking at stuff like that? That kind of a number? Right, okay. So, yeah. But as I say, your graph gives the right answer, because your line of best fit, my line of best fit is going to be slightly different. Okay, but we're all going to be in around the same area, right? Are we all okay with line of best fit? Right, so you draw your line, get through as many points as you can, but make sure there's kind of equal number of points on either side of the line, right? So if there's 8 points, I made sure there was 4 on one side and 4 on the other, and I think I only went through 1, so there was 3 on one side and 4 on the other. That's fine, right? Okay. Then you get 2 points, right? Okay, I get 2 new points, right? Get your slope, get your equation, sort it out, use your equation then to answer the question. Are we okay? Any questions on line of best fit? No, right, okay. That was the last sum. Do you want to write down some of the notes on line of best fit? It's not excessive. Where am I? I think we've written down, have we? Yeah, I have no notes on line of best fit. I thought I had. Yeah, I deleted the page. I knew I had. Right. Right, girls, the projector it won't connect for me. So would you be able to read it like this? Yeah. Can you read it like that, please? Yeah. Is that okay? So, the line of best fit is a line that is drawn to pass as close as possible to all the points on the scatter diagram. It can go through some or all of the points, right? And it is drawn by the eye. That means we're all different. Okay, all our answers are different. And then to find the equation of the line of best fit, find 2 points on the line, right? 2 new points if you haven't gone through 2 exact points, right? Use the slope formula to find the slope of the line, use the line slope and one of the points to find the equation of the line. Is that right? Okay, easy peasy, yeah? Right, okay, we're not taking down that example because that was the one you just did for homework, is that alright? Okay, are we all finished with that?
Yeah.
Right, don't write, right, for the moment, I just want to start on the normal distribution. I want to talk about it, but we'll write about it tomorrow, okay? Right, so what's called the normal distribution, and is really important in statistics because there's loads of formulas, right, okay, there's loads of formulas that apply to it, right, okay, and loads of rules, and statisticians, that word, have been working on the normal distribution forever, right, okay, and there's a poster down on the back wall. By the way, the back wall there is for you. The standard graphs, the series, the normal distribution, they are higher level stuff, okay, right, but any survey we do, right, okay, so any survey we do, so let's just say we're doing the height of everybody, right, okay, in Laurel Hill, and we're going to do, this is the frequency, as in how many people. So the height, these are the small people, right? These are the teensy people down here. These are the really tall people up here. So the height is a number that gets bigger, right? Okay, so there's very few teensy people, right? Okay, right? And then we get taller, and we get taller. Most people are somewhere in here in the middle, right? Okay, and then we get the same kind of a look at the other side, right? Most surveys fit into, will give you that kind of a histogram. So if I change that to weight, right, you get the exact same histogram, shape histogram, right? It might be more spread out, it might be tighter, right, okay, but the shape would generally be the same. As in, it starts low, right, it gets high, right, and then it goes back low again, okay? And it's completely symmetrical, okay? As in the mean, the median and the mode, that's the axis of symmetry, and it's also where the mean, the median and the mode are. They're exactly in the middle, right? So the majority, now there's always an oddball, right, okay? But the majority of surveys will be like that, right, okay? Your IQ, people's IQs, right? The people who watched Game of Thrones, right, okay? Right, how much they watch, no, that's not a good one, because I can't, but, do you know, but, yeah, people who watch, no, I can't put, yeah, frequency, the number of people, yeah, it doesn't matter. Right, okay, any survey though, height, weight, IQ, right, who likes the biscuits? Right, you'll find very few hate them, very few love them, most people are somewhere in the middle, right, okay? That's the way I'd feel about the giant Skittles, right? I'd say a few people hate them, a few people love them, and the rest of us are in there, I'm sure if there's nothing there, I'll eat, nothing else there, I'll eat them, right, okay? Where are you? You're down here? Oh, you love them? Right, okay, right, okay, but most surveys, right, will turn out like this, right, the majority of surveys will turn out like this, and if you draw a histogram, right, and then draw a curve over the histogram, you'll end up with a curve that starts low, right, and finishes low, right, okay, and it's completely symmetrical about the middle, and this is the mean, the median, I'll put MMM, the mean, median and mode are on the axis of symmetry, right? One side is exactly the same as the other side, okay? And this is called the normal distribution, right? So this is called the normal distribution, right? And as I say, it's true for most surveys, right? I'll give you the notes on this now tomorrow and stuff, right? But I just wanted to introduce it because I have a few minutes left. Okay, so sometimes, girls, it could be, right, it could be very tight. Okay, it could be like that. Sometimes it could be very spread out. Okay, but the premise is the same, that there's very few small, most people are in the middle, and then it gets small again, and it's completely symmetrical. Okay, so it's completely symmetrical. Yeah, I know what you're thinking. Stop it. Right, okay, so that's what a normal distribution is, right, okay, so a normal distribution starts small, right, it goes, right, okay, there's one, right, and another one could be, right, it could be actually quite narrow, right, okay, it's supposed to be roundy at the top, be quite narrow, right, okay, would anyone be able to tell me what's different about, what number would be different between these two distributions? They're both normal distributions, they're both completely symmetrical, they both have the mean, the median, the mode in the middle. What's different about them?
One of them is more spread out.
One of them is more spread out. So what number describe? Yes, they have different standard deviations. Right, okay? Yeah. Well said, Bo. Right, okay, so they have different standard deviations. Remember we talked about spread, right, okay, and standard deviation we said was going to come back at us again. Here it is coming back at us. right? So they've got different standard deviations, but they still fit a normal curve, right? Will you do page 294, number 10 and 11 for me? They're on line of best fit. Page 294, 10 and 11, right? Line of best fit and scatter diagrams, okay? Right, I also, girls, oh yeah, thanks. I also photocopied an exam question. It's question 1 of 2024, leaving third paper. It's algebra, right? Do not look up the answers, right? Please do not look up the answers during yourself, right? And waste my time. What am I correct and perfect answers for, right? We want to make mistakes and learn from our mistakes. Right, okay? So, I'm going to give you a question a week, which is it's a 30-mark question. So that means it's going to take max 15 minutes. So, if I give it to you on a Monday, will be handed up by the following Monday?
Yeah.
Right. Except for this week. If I give it to you on a Thursday, can you hand it up Monday?
Yes.
But I'll have the next one on Monday. I'll be organised next week, I promise. Okay? So will you grab one of those on the way out? So, right.